people start even though there's still people coming in, so you don't have to start late, and so you can also finish in time. So now I give the floor to Tom.
Okay. Great. Hi everyone, can you hear me? Yeah, great. So my name is Tali, and I'm a master's student at Ben-Gurion University. This work is part of my thesis, and I worked with Evyatar Erell and Svoray on quantifying the psychological effect of vegetation on physiological heat stress. To introduce our research, let's begin by envisioning a scenario where my supervisors and I visit a cafe under specific meteorological conditions like this. Now, on the next day, we revisit the same cafe, only to find out that the tree has been planted there. Now, in this hypothetical, very hypothetical scenario, we are all dressed in the same clothes, as you see, and the meteorological condition remain unchanged. Now consider this. Where do you think you or any other person would feel warmer? Here or there? Interestingly, many individuals think they will feel warmer in the less vegetated environment, even though the meteorological condition remain consistent. Now you think this is true, but actually it's never been examined. So this phenomena piqued our curiosity and prompted us to delve deeper into this matter. There are well-known theories that relate to vegetation, to benefits of vegetation in diverse settings. Psychologically, vegetation studies have shown that seeing vegetation shorten recovery time and improve well-being. Physiologically, vegetation reduces heat stress by the evapotranspiration effect and shading. While some studies explore the positive effect of vegetation on thermal comfort, in addition to its modifying of our physical environment, no one has actually measured this effect and the potential link between the psychological and physiological benefits. So our study is the first study to actually measure the psychological contribution of vegetation to reduction of the physiological heat stress and to correlate between both the subjective assessment of the thermal comfort and the accurate measurement of the environmental conditions. So our research questions is whether there is psychological effect of vegetation to reduce physiological heat stress, and we break it down into 3 key points. First, we inquire whether such an effect exists, and if it does, will vegetation improve symptom of stress regarding the subjective response and the exposure to hot, very hot in Israel, meteorological conditions? Second, what is the minimum amount of vegetation that's required in order to feel this effect? And third, we investigated whether there is a threshold temperature at which vegetation starts to mitigate heat stress. In order to answer these questions, we did a field research. We tested 8 sites with different vegetation cover around Sheva. It's a southern desert city in Israel. There we tested 322 subjects and employed on each one of them 3 techniques. First, environmental-wise, we measured meteorological conditions. Answering the psychological question, we used questionnaire. And addressing the physiological stress, we measured biophysical metrics of the subject, like heart rate, using empathic bracelets. This example of 2 of our test sites with less vegetation and more vegetation. And to measure the the vegetation view, we took fisheye photo of the view seen by each of the subject. Then we analyzed this photo using machine learning process in order to compute the percentage of vegetation seen in the field of view of the subject. We measured also the meteorological measurement that the subject were exposed to using this Kestrel device, and then calculated a PET score that gave us the objective heat stress. Subject also filled up a questionnaire about the thermal sensation, preference, and comfort, demographic questions such as age and gender, and question about the clothing and prior activity. We used empathic bracelets to measure the stress of the subject by calculating their sweat levels, which is also EDA, or electrodermal activity, that you see here in the y-axis, So this point is an example of high stress and this of low stress. After that, we had to process the EDA into SCL, or skin conductance level, because it's considered a good indicator for subject stress levels. After the data collection and data cleaning, we started with the statistical part in order to get the results. So to examine the psychological effect, we use ordinal regression analysis when the PET was the independent variable and the dependent variable was one of the thermal answers. In this slide, I will talk about thermal comfort. So I won't delve into the details of the ordinal regression because it's quite complicated. So the key takeaway is the visual representation. Now here, every horizontal line represent a group of subjects that sharing a similar vegetation coverage, like these two photos. So the x-axis is vegetation views. The y-axis is about odds ratio, which indicating the likelihood of a decrease in thermal comfort with one increase in PET unit. So as you see, the general trend of the black line aligns with our initial assumption, with one exception of that decrease here. We find out that this is due to a slightly lower PET values within those low vegetation groups that colored as blue, as you see in the legend. And then when we try to remove this kind of cooler, not that cooler because it's 32 PET, yeah, but when we remove these cooler outliers, we got this consistent trend that shows that at high vegetation groups, the odds of decreasing thermal sensation are lower when PET goes up by 1 unit than the odds at the low vegetation groups. Notice that the range of the PET is quite narrow, so we can say that at the same PET, we feel more comfortable with more vegetation. Similarly, the preference trends behave also as we expected, so we can say that with less vegetation, we would like it to be cooler. And about the thermal sensation, we also see a little bit lower, less smoothly trend, but still we can say that with more vegetation we feel cooler. Notice this significant decline of the odds ratio within the low vegetation groups up to about 20% of vegetation. So addressing the physiological effects, we use the Empatica bracelets, as I mentioned, to monitor the biophysical measurements of the subjects, like stress. And because these variables are continuous, we could now use linear regression analysis. In this analysis, we set the logarithm of PET as the predictor and the logarithm of SEL, a continuous variable of indicator of stress, as the dependent variable. In this graph, we see the predicted linear regression lines that correspond to the low vegetation groups. Similarly, these kind of green-brown lines correspond to the medium vegetation groups, and this green to the high vegetation group. A noteworthy pattern emerged here, starting at PET of about 33 that correspond to an exponent of 3.5. We see a slight elevation in stress in low vegetation groups. That means that for the same PET, vegetation lower physiological stress as we expected. Due to our multidisciplinary nature of our research, I have a lot of points to discuss on, but since I have a little time, I'll describe only a few. First, what is the exact size of the effect we measured? For example, will an increase of 10% in vegetation will reduce our feeling of heat stress by 1 PET, perhaps by 2? We don't know that. It's important to know that the statistic we're dealing with present odds and not exact values. Second, does vegetation necessarily have to be in our field of view? We analyzed photo of what the subject actually saw in front of them, but what about the back view? When we are sitting in a cafe, we're sometimes looking backwards, right? So perhaps also the back scene have an influence on our psychological and physiological perception. And third, what about artificial vegetation? Maybe we can save money and have the same effect in urban environment, not by planting real trees and invest in their irrigation, which is scarce in Israel, and instead put a plastic vegetation instead. In conclusion, our novel field research includes an extensive dataset and employs a diverse range of methodologies. It's offering a compelling indication that vegetation indeed impact our psychological thermal perception and physiological stress. And looking at our initial research question, we address each part of it. Physiologically, we saw more stress in less vegetated groups. Both the psychological and physiological effect starts to appear significantly after a PET value of about 33 degrees. And how much vegetation do we need to feel this effect on thermal reduction? So if we are looking on thermal sensation, the effect became most pronounced up to about 20% of our vegetation view. But if we are including both the preference and comfort, the more vegetation is the better. And to, sorry. Okay, in essence, our research underscored the nuanced relationship between vegetation, heat stress, and human well-being. It's establishing a threshold and shedding light on the connection between our psychological and physiological states and our surroundings. And that's it. Thank you. And if you feel hot, so please look at the tree.
Please, if there are questions, raise your hand.